just...
Hi, Lebo.
Hey, welcome,
Hello,
welcome.
Sandra.
Okay, so the topic we're going to be covering today is called statistics, or in some teachers call it data handling. And so when we talk about statistics, we often have data, and I just want to give you some words that go with data. So when we talk about data, we often have data as numbers or data as words. So the fancy, way of saying data as words is qualitative. Basically, it just means the data is expressed in letters or words or, ABCs, etc. However, in this section, the most common type of data you will see is called quantitative data, like quantities of data. And when we talk about those types of data, we have two types of numerical data or data that comes in numbers. We have discrete and we have continuous. And I'd love to ask the class, has anybody heard about the difference between discrete and continuous data? I will explain it to you, but I'd love it if somebody has maybe heard about the difference, or their teacher has said to them, how do you recognize whether data is discrete or continuous? What's the difference between the two? And if you know, just pop your hand up. And even if you just know part of the answer, what is the difference between data that is, or they're both data as numbers, but if I say to you data is discrete, it's a discrete versus continuous. What is the difference? Does anybody know? What question should you ask yourself? So if I ask you, how many people are there in the Zoom? Is that discrete or is that continuous data? That's a good question to ask. Let's go to Lusanda. Lusanda, what do you know the difference between discrete and continuous data?
Yes, sir.
What did your teacher tell you about this?
I think discrete, it's not a decimal number, and then continuous, it's a decimal number.
Okay, so this is one of the ways of describing it, and you're right. So normally discrete data doesn't have any extra fractional bits, whereas continuous data can have like a decimal point and like extra little bits of fractions. So that is true, but there's also some more about the difference that is quite important. So Nawazi agrees with you. Does anybody know anything else? So if we come back to that question, how many users are there in the Zoom right now, and is that discrete or continuous? Let's go to Kuchle. So Kuchle, what do you think?
Hi, sir. I think discrete data is like a whole number.
Okay.
If that makes sense. And then like continuous data, like as you said before, is more of a decimal. So for example, a person would be discrete data because you can't have like half of a person. And then continuous data would be like a shoe size or something.
Yeah, or your height. It could even be like, different bits. Okay, that's fantastic. Thank you so much. So what we say as teachers is, if you can count data, it is discrete. If you can measure something, it's going to be continuous data. So if you count it, it's discrete. If you measure it, it's normally seen as continuous data. And so as an example, the number of people that would be, I can't, yeah.
I'm not sure if it's you or me, but there is a bit of a lag.
Okay, let me go to my mobile data. Give me a second, guys, and I will. Level, can you hear me? Is that good?
Yes, I can hear you, Mr. S. Yes.
Okay, fantastic. So what I was basically saying is that if you count the people in a Zoom, that would be discrete data. If you measure the different heights of people in the Zoom, the heights of the students in the Zoom would be continuous. Okay, so that's an important idea as we go forward. So let's just do an example I have here is, another example is discrete data. If you have 2 dice and you roll them, then if you get the sum of those dice, that data will be discrete, because you can't have 6.5 if you're summing up 2 dice. You can only have whole numbers. So the sum of dice would be discrete data, but a person's height or the time in a race, or if you measure it, it would be continuous data. And continuous data can take on any value in a range. So you can have 1.555, and that would still be a valid continuous data item. So normally in grade 11, that's the main difference you need to know. You need to know the difference between continuous and discrete data. So let's do a little set of questions together to see if you understand this difference. Okay, so here is your question. Which one of the following options is discrete data? And these are all different facts about Sam. What are the options do you think are involved there? Aha, I see Asanda, Tulelo, Yandisa. Okay, fantastic. So I see people are saying B, and that's because this data set is counted. There's 2 brothers and 1 sister, and so essentially because you're counting it, it would be discrete data, whereas the rest of the data sets are all measured. So you measured all of these guys. So your guys are spot on. Well done. Nicely done. Let's do a different one. I don't know how many of you like cats. So which one of the following is continuous data? Okay. Awesome. You're quite right. You normally measure someone's weight, and it's possible for the cat to take on any number of values, and so C will be the correct option. Okay, so what I want to know is, are there any questions about continuous and discrete data? And if there are, please do raise your hand or put it in the chat. Otherwise, if you feel like you understand the difference between continuous and discrete, won't you just give us a thumbs up? And if you don't understand it, give us a thumbs down. Okay, awesome. So again, if there are any questions, basically what I come back to is, if I can count it, it's discrete. If I measure it, it's continuous. Fantastic. Now, the other thing that I want to talk to you about data before we get going with the other part of today is, sometimes data can be placed in a list and sometimes data can be grouped together. So say, for example, I'm guessing the height of people in this class. So let's say I go 161 centimeters is one person, 163, 171, 175, 181 centimeters, 190 centimeters. This is what we call a list of data, okay? Because there's individual items. And so for the first 4 lessons of the series, we will be working with lists of data. However, not all lists are sorted from smallest to biggest. So at the moment, my list goes from the smallest item to the biggest item. But if it is possible that my list could have like 169, and so sometimes when we have lists of data, we also have to sort them from smallest to biggest. That can be helpful. Okay, so we will talk about lists of data, but in other times in the series, we will talk about groups of data. And so what would that look like? Let's have a quick, let's make a few intervals here. So let's say we had from 160 to 170, and then we had from 171 to 180, and then from 181 to 190. And so in the section, sometimes what you'll see is you'll have an interval, and then you'll have something called a frequency, or how many times that thing occurred. So how many items do you think there are going to be in this very first interval? If you look at my list, how many items are there going to be in the first interval? So in the 160 to 170 interval, how many items are there going to be? I thought I was going to catch some of you with 2. Okay, so in that first interval, if I was grouping it, these 3 items would occur. And I see that most of you have got that, or if I caught you, I think you see quite quickly why the 169 would be included. And then, what do we get for the second interval? So the second interval will just be 2. And then what's the third interval going to be? Yeah, it's also going to be 2. Okay, so as we come to this section, not only do we need to know about different types of data, we also need to know that when we work with lists of data, it can work a little bit differently to when we are given groups of data. And so groups of data, we will deal with mainly in lessons 5 to 8, whereas lists of data will be pretty much today and the next 3 lessons. Okay, give me a thumbs up if you understand the difference between lists of data and groups of data. Give me a thumbs down if you don't understand the difference between the 2. Awesome. Okay, so we are building our foundations of knowledge. If you have a question, please do ask it now about this topic, because I see that mostly we have thumbs up, I think. But I'd love to answer your question if you are feeling a bit confused. Okay, cool. Let's get going then. So if we have a list of data, the 3 things we are going to learn about today are measures of, if I have a data set, where is the middle? So often in life, we will have a collection of data. It may be big or small, and we are interested in knowing where the middle is. Now, you may think, oh, that's easy. The middle is just the middle. But as you think more about it, you realize, oh, this word middle is a bit of a there's different ways of finding the middle. And so in mathematics, the one way of finding the middle is called the mean. And a fancy way of saying it is it's a measure of central tendency. So where is the middle? And how do you find the mean? You add up all the numbers and you divide by the total amount of items in your list, your set. Okay, so one of the students has asked me to repeat the difference between lists of data and groups of data. So I'll just very briefly go back to the previous thing. If you're given a list of data, they're just a whole bunch of individual items. Whereas if you've got a group of data, you will normally have an interval or a group in which the data fits, and then you'll have a count of how many items there are in each interval. And so in this particular collection that we had here, we had 3 items that were in the very first interval. They were between 161, 163, and 169, all fall in the interval 160 to 170. And so grouped data just means that we only list the number of times an item occurred in that interval, whereas a list of data lists every single item. But we'll do it in more detail as we go forward. Okay, then the next thing is called the median. And the median is a little bit different to the mean. The median, you list all the numbers in order. Now, when they say in order, they mean from smallest to biggest. So from smallest to biggest. And you then have to choose the middle one. And so we're going to see an example of that in a moment. That's one that's a little bit new here. And then the mode is the measure of the middle. Basically, the way you find the mode is it's the value that occurs the most often. So if you see that number coming up the most times, that's the mode. So I think most of you will have seen these things before, but I'm not 100% sure. So let's go through an example together. But basically, we have these three measures of where the middle is to get through today. So for now, we are going to try and calculate the mean, the median, and the mode. And I want you guys to try and find for me first, find me the mean for this data set. And the mean is going to tell me roughly where the middle of this data set is. So off you go. Find me the mean of the data set. So in order to find the mean, I need to know how many items there are. So there's 9 items. And if I sum up all of,
7 is 3.
okay, so if I sum up all of these, what do I get? 1 plus 2. So sum them all up. I get 27. And so what is 27 divided by 9? It's going to be 3. So we say that the mean is 3. So just to clarify, how do we find the mean? We add up all the items, we put it on top, and then on the bottom, we say how many items did we have, and we divide by that, and we get 3. So before I move on, are there any questions about the mean? Does anybody want to clarify or check? Some of you got 5 at the beginning, and I just want to see if we... Okay. I'll give you a moment. Are there any questions about the mean? Okay, then we're going to move on to what's called the median. And what I want you to do is, before you find me the median, when we spoke about how to find the median before, we always had to list our data from smallest to biggest. And as I look at this data set here, I want you to recognize it is not written from smallest to biggest. And so I want you to start by finding where is the, write the data set out from smallest to biggest, and then work out the median. And you can also work out the mode at the same time. So let's all do that. And then you can put your answers in the chat. So 1, 1, 1, 2, 2, then 3. And then what do we have? Then we have 5, 6, 6. Okay. So where is the middle of my data set? Well, there were 9 items. And so you should find that this is the median, because you have 4 items on this side and you have 4 items on this side. So we have the median as 2, and then the mode is the measure of the middle that occurs the most often. I see a couple of you have put this in the chat. Which number comes up the most often? Okay, it should be 1. Yeah, exactly. So finding the middle of the data is actually not too bad. All we need to do is make sure we understand what each of these things means, and then know the little bits of calculations that go with it. So what I want to suggest is that finding the median can be a little bit harder if you have a longer set of data. In this particular set of data, it was easy to see where the middle was because it was a small data set. Has anybody learned any other formulas for finding the position of the median? And if you have, would you be willing to just quickly pop your hand out and tell us what you learned in class? Because I'm going to show you a way to find the median. So let's go to William. And then William, what do you know about finding the median? Maybe to make it a bit easier if the data gets bigger.
When finding the median, if data is too big, and specifically if all the numbers make a even number, you take basically you halve the number of numbers they are, then you find the two middle numbers and divide them by 2 in order to get the median.
Okay, we'll deal with that situation now. You're absolutely correct. But if the median falls between two numbers, we average it out, which we'll see today. But there's another position formula that I think maybe some of you have learned about. I just want to check, then I'll explain it to everyone else. So Lasanda, do you have an idea that you want to share or could share about finding the position? Yes, Ayanda, using Q2, yeah. Lasanda, can you hear me? Okay, let me show you guys. All right, so just while we're doing this, another way of writing the median, sometimes we call the median Q2. Now, that won't make any sense yet, but it will come up in the next lesson, so I want to point that out. The other thing is often we use what's called a position formula for the median. And I want to show you how we do that. So if you've got 9 items in your collection, to find the position of Q2 or the median, what we do is we say, we use the formula n plus 1 times a half. Now this is going to sound a bit weird, so just stay with me on this, stay with me. In this particular data set, how many items do we have? We have 9. Okay, so what I'm going to do now is I'm going to replace the n with a 9. Then we know that 9 plus 1 would be 10. And what is a half times 10? It's 5. Now, that is not the number 5. It is the position 5. So we go to our data and we count to position 5. Position 1, 2, 3, 4, 5. So I want to point out that instead of having to visually sort these 2 items out, I could use the position formula for the median. And all I do is, because it's the median, it's a half in front, and I go a half times n plus 1. Then I can find this in my data set. Now, I just want a quick check from the class. If you've seen that formula before, give a thumbs up. If you've never seen that formula before, give a thumbs down.
Mr. S?
Yeah.
Kito is asking why we add 1 in the bracket.
The reason we add 1 is to get us to the middle of the data. Kito, I'm not going to be able to explain that very, very quickly today, but just to know that we always use n plus 1, because if we just used n, we wouldn't find the middle. It's because of the difference between the amount of numbers and the amount of spaces between numbers is the quickest way I can answer you. But just for now, trust me for now. Okay, let's move on to a second example where it is a longer data collection, and we're not going to finish all of this right now. But I do think my formula will be helpful for you in this. So what we see in front of us is a stem and leaf plot of data. Now, you may have seen a stem and leaf plot. You may not have seen a stem and leaf plot. I would like to know from the class, what is going on in this picture? What is being given to me? And if someone could just come online and explain to me what this is giving me. And our goal in this question, our goal is going to be to find the median, to find the middle of this data set. But before we do that, I need to know what the stem and leaf thing is all about. So who is willing to share a little bit about what does it mean when I say 1, 1, or there's a stem of 1 and a leaf of 2? So, yeah, Kuchle. what have you seen a stem and leaf plot before?
Yeah. Yes, I have, sir.
Okay, tell me what's going on. It looks a little bit confusing. Tell me why it's
so in this case, I think the stem is giving us the tens and then the leaf is giving us the units. So 1 and 1 is 11 and 1 and 2 is 12.
So the very first two items in this data set are 11 and 12. What are the next two?
21 and 23. Or are we going to the next?
No, we're going to literally in order. So
okay, 13 and 13, sir.
13 and 13, exactly. And what is the last number in this data set?
19.
That's on the first stem.
72. Yes, sir.
Okay. And then is this data already ordered, or is it mixed up when you look at it?
It looks ordered, sir.
Yeah, it is ordered. So one of the reasons we like giving stem and leaf plots in exams is it saves the students working. And so this is a quick way of writing a lot of data. And so often when you see sets of data, we present them in a way that it's a little bit quicker to write. Now, that was fantastic. Thank you, Claire. So everyone, this is a data set that we've got here. Now, the next thing I want to know is how many items are there in this data set? So I want you to count with me, and I want you to help me find how many data items are in this data set that are in this type of graph called a stem and leaf plot. And I want you to try and count with me. Okay, so when we talk about data, we often talk about the number of items in the set as little n. And you will notice here that there are 29. Yeah, so if you count them, and we would see that they're the most data items that have, like with 110, and you can see there, you can see almost how many data there is in each sort of category here. Okay, now, I want to find the median, the middle of this data set. And what I want you to do is I want you to try and find me the median, but I'm going to give you the position formula for the median, and I'm going to use the symbol Q2 for the median. And remember I told you the position formula is going to be that. Now I want you to use that position formula to find me Q2, or what we sometimes call, well, what we often call the median. So take a moment and look through this data and then find me the value of the median. So in this case, I know that n is 29. So I'm putting it into my formula. So I've got 30 times a half. So the position is 15, but the value is not 15. So how do we find the value of the number in position 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we would say that the median has a value of 27. And I think you can see why using this formula is so much quicker once the lists of data get bigger. So I would like to check from the class, I'm sure there's some questions about, there's two different formulas. We first find the number of items in our data set. Then we use this new formula, which is a half times n plus 1 to find the middle, the position. And then we literally go and count to position 15. Are there any questions from the class? Because I'm sure lots of students are still thinking about this. Okay. Now, before we take our little break, I want to know, looking at this data set, what is the mode of this data set? So this data set has lots of different items. I want to know what is the mode in the data set. Okay, and there was a question, sir, can you pick whatever formula you're most comfortable with? Nate, you can use whatever as long as you're consistently getting the right answer. However, when we get to things like quartiles and other types of things, it is helpful to use this formula. So you can use it for the median, but by the time you get to something called quartiles, you'll have to start using this idea that you calculate the position. And then after you calculate the position, you find the actual thing that you're looking for. So what was the mode? The mode was the thing that occurred the most often. And it looks to me like there's lots of 7s here. Now, the mode is not 7, because remember, these numbers mean 17. And so the mode is going to be 17 in that situation. Okay, cool. Now, I'm not going to ask you to find the mean in this situation, but just know that if you did need to find it, you would just add up 11 plus 12 plus 13, and you'd add up all the numbers, and then you divide by 29. But our real focus for the rest of the lesson is going to be around these things here. Okay, but before we do that, we need a break. So I want everyone on their feet, and I want you stretching. And Lebo, if you can please lead our students in encouraging them to do a quick stretch.
Come on, guys. Give your body a break. This is a nice little break.
You will definitely feel awesome afterwards. So
yes,
if you can
William is getting in on the action.
Hand to the side, opposite knee. See if you can do crossovers.
Come on, Asanda. Karabo.
You can do it, man. You can do it.
Yes, guys. No lazy, spacey.
Stretch it out.
Nompa. Come on, Aluto. I'm sure your body could use a stretch. Sitting for
guys,
30
you missed
minutes.
out. If you haven't joined, trust me that you will enjoy the second half of your lesson much more if you've stretched. Take a nice deep breath, and let's get the show on the road again. All right.
Nice one, guys. I hope you feel refreshed after that.
Okay. Now, I have a little question for you, a little brain break. Can you solve this one? Now, this isn't normal maths. So you have to think about what patterns are involved. Okay. Zinhle, I think you're onto it. Who else agrees with her? Or how did you do that, Zinhle? What was your thinking? Who else has a add and swap them? So add, so 21 plus 32 is 53, then we swap them, yeah. 33 plus 42 wouldn't. So that would be 75. Okay, everyone's like, okay. Do you guys see this? 2 plus 1 is 3. And what's 3 plus 2? It's 5. So 3 plus 3 is 6. 4 plus 2 is 6. So what is this going to be? Okay, indeed, 5 plus 1 is 6, and 2 plus 6 is going to be 8. And so our final answer is going to be Kitzel. They are getting a bit harder, yes. But I wanted to do something a little bit different. So, yeah. Awesome. Okay, everyone, let's get back to the second part of the lesson. But yeah, I hope you enjoyed today's little brain break. It was something a little a little different. Okay, let's not do stem and leaf. Okay, let's do this. So let's start. This is a data set. And what it is it is months of the year, and it's the average temperature for London, England for each month of the year. And it's given in Fahrenheit, which is a different scale. I want you to try and find the mean temperature for the year for London. And once you've decided what the mean temperature is, I want you to choose the option from A, B, C, or D. Now remember, the mean is a type of central value or central tendency. It's where is the middle of the data set. So you're basically finding the average temperature for London, or where essentially. Okay. So ask yourself, what are the first steps with the mean? With the mean, you need to sum up all the data. So sometimes you even see like sum up that and you divide by the number of items. If it's months of the year, I must be dividing by 12, which is a good sign. And so now I just need to sum up all these things. 38 plus 39 plus 43. 52 plus 58 plus 51 plus 44 plus 42. I get 554, and I must divide it by 12. Oh, did I add up wrong? Let's have a look. I probably did. 38, 39 plus. Plus 51 plus 44 plus 42, 594. I left out one of them. So 594 divided by 12. And we should get 49.5 Fahrenheit. Yes. Okay. So that wasn't so bad. Not too bad. Okay. Now, that was the mean. I want you to find the median for this data set. Now, this is a slightly different idea. And so before we even, so I want you to find the median for this data set. And I want someone to tell me what is the very first step we need to do if we are going to find the median of this data set. It's not currently done for you, and you need to recognize that. What you're paying, yes. What you're paying? Do you want to unmute and tell us what?
Sir.
Yeah.
Yes, sir.
What do we need?
So you have to like firstly arrange the data in ascending order.
Very important. So 38, 39. Oh, I see what you mean. There's 42 down here. So we've done that. So 42. Then we have 43, 44. We have 46. And what do we have after that? We have 51, 52. And we have 57, 58, 62, 62. Fantastic. Yes. Okay, now we have to find the middle of the data. Now, there's two ways you can do this, but the problem we have this time is that the number is 12, which means it's going to kind of fall halfway between. It's going to fall somewhere between that one over there. I would use the position formula. And so I'm going to say, what is the position of the median, or Q2? So position of Q2 would just be a half times n plus 1, which is going to be a half times 12 plus 1. And that is going to give us the position of 6.5. Now, we haven't had a fraction before. What does it mean, Zinclair, if I get a position of 6.5? How am I going to find that number? Do you want to help us, Sinclair? Because I haven't done one where we had a halfway between two numbers. Or Kuchle, what do you think we should do?
So I used a different method. So I arranged the numbers in ascending order, and then I like used my fingers to get to the middle, and my middle numbers were, I think it's 46 and 51. So I added those and divided it by 2, and I got my median.
Okay, so that's what I'm going to do as well. So basically what happens is if you get a position number that is a fraction, it means it's between the 6th and 7th number. And so what we're going to do is we're going to average it out. But first we need to count from the beginning. So let's do that. So 1, 2, 3, 4, 5, 6, and then 7. So actually my median is going to be between these two numbers. Can everybody see this? Check this with me. So 1, 2, 3, 4, 5, 6, 7. Yeah. So we're in position 6.5, which is halfway between these two numbers. So what I need to do is average out these two numbers. And I'm going to go 46. So 46 plus 51 divided by 2. And then what do we get then? So 46 plus 51 divided by 2. We should get 48.5. Okay, so now things are getting a little bit trickier in that we now had to arrange the data from smallest to biggest ourselves. We then had to find the position of the median, and the position number was a fraction. And then when we found that position, we had to average it out because it fell between the two values. So the median will be 48.5. Now, I know that there might be questions. So if there are, please put them in the chat now or raise your hand. But yeah, I think we get a good basic idea of how this works. While we're waiting for questions, who would like to tell me the mode? What's the mode for this particular data set? Yo, that was quick. So the mode for this data set is going to be the one that occurs the most often, which is 62. But now I want to ask you a question, guys. Do you think 62 feels like the middle of the data to you? So 62 is the mode, and the reason it's the mode is that it occurred twice. But do you think 62 is a good value for the middle of the data? What do you think? Does anybody have an opinion? Part of me thinks, I know that the mode is meant to be the middle of the data, but it feels like 62 isn't a very good middle. Okay. So what I want to point out to you guys is that even though you can calculate all three measures for the middle of the data, depending on the data, sometimes the median will give you a more realistic middle than the mode. And so we use, for different types of data, we sometimes use different measures of where the middle is. And so I just want to check, can you all see that? Can you see how that sometimes the median is a better measure of where the middle is? Sometimes the mean is. Can you see that sometimes they give quite different values? Give me a thumbs up if you get that. Okay. And then let's finish with one more question like this. Or maybe two more. This is a multiple choice question. And I want you to find me the median from the following list of numbers. Find me the median. Find the median from the following list of numbers. So ask yourself, what's step one if I've got a list of numbers, what's step 1, and then what's step 2, and then what's step 3? And I'm looking and I'm going, oh, I wish they'd given me this data in a stem and leaf plot. Then life would have been so much easier. So I know 48 is the smallest. Then 52, 58, 60, 60, and then 67. Okay, so in this data set, we know that there are 6 items. N is 6. And so if I was now, I think a lot of you can see that the median is going to fall between these two. And so you probably don't have to find the position formula for this one. The position formula will still work, but I think a lot of you can see now that you find the middle of these two, and what's 58 plus 60 divided by 2, it's 59. And so the answer is going to be C. Now, if you had used the position formula, all that would have happened is you would have got a half times n plus 1, so 6 plus 1. So your position would have been 3.5. So that would have been the position. And so that would have meant, where is position 3.5? Well, 1, 2, 3, 3.5 falls here. And so it would have told you the same story. Okay, so the answer is C. All right, so today's lesson was all about what are the different types of data that we encounter, and how do we begin to find the middle of the data? And there are 3 ways to find the middle. There is the mode, the mean, and the median. And probably the most difficult to work out is the median. And so we're going to practice that a bit more in the next lesson. Okay, cool. So Lebo, if you could please put the poll out to the students. Guys, it really helps us if you give us some feedback on the pacing of the lesson. And so just to finish today, if you could help us by filling in the poll. And yeah, thanks for attending today. I hope that you've enjoyed the lesson. And I hope that I will see you on Wednesday. And we can continue from there.